Okay, in this video we're going through chapter 4 part 1 on simplifying algebraic fractions. So I don't need you to watch this video. We take a look at numerical fractions, what we have learned in primary school. So basically we have a numerator at the top and a denominator at the bottom. Both of them, they are integers and we cannot have the denominator as 0. So these here are 3 examples of numerical fractions, and as you can see, they can be positive and they can be negative. So for an algebraic expression, which is the topic for today's notes, we still have the same format, numerator and denominator, but this time one of them or both of them could be algebraic expressions, and again the denominator cannot be equal to 0. So here are some examples. As you can see, we have cases where either the numerator is equal to 0, equal to an algebraic expression. We have both of them, both top and bottom algebraic expressions. We also can have an example like this, 2 over x plus 1. So this is a case where we have the denominator as an algebraic expression only. Then some of our basics that we have learned in primary school. Now we know that 4 over 6 is equal to 2 over 3, and what does the working look like? So all we needed to do was to divide both numerator and denominator by 2, so that we result in 2 over 3. And we say that 4 over 6 and 2 over 3, they are equal to each other, they are equivalent. So whether you choose to divide both numerator and denominator by the same value or expression, or if you choose to multiply both numerator and denominator by the same value or expression, you still get back the original expression. They are equivalent. So this same idea can be applied to our algebraic fraction. Now, the equivalence over here, what we tend to do is to just cancel. Okay, we say we are dividing by 2. So we're left with 2 and we're left with 3. So this idea of cancelling only applies if there are common factors that we are dividing. Okay, so let's take a look at this example over here. We've got x squared multiplied by x plus 2. So here I've got a factor x squared. This is another factor x plus 2. The entire thing is a factor. Whereas the denominator, we've got a factor x. So what does this example show? It shows that this person is trying to cancel away the 2 x's over here, and therefore resulting in x squared times 3. So if we were to continue the working, it will look like this, 3x squared. And apparently, this is wrong. Okay, so let me illustrate why it is wrong. Now, using this numerical example, 2 times of 1 plus 9 divided by 3, we know that we're going to work out the brackets first. So this gives us 20 over 3. Now what happens if, we know that this is correct, huh? Do brackets first. So what happens if we try and cancel the 9 and the 3? So this is what's going to happen, huh? 9 and 3 divided by 3, we result in 9 and 1. So this will give us 2 times of 4, which is 8. And clearly, these two are different values. We know that the second one is wrong. But why is the act of cancelling the 9 and the 3 wrong? So the reason is because this 9 is not a factor of the numerator. The factors of the numerator are 2 and 10. Now we know that 10 itself has other factors, 2 and 5. So that is the reason why we do not cancel off the 9 with this 3 in the green color working, because the 9 itself is not a factor. 9 has to be added to 1 to give us 10, and the 10 is not a multiple of 3. So back to this. So as mentioned at the start, x plus 2 is the factor. This particular x itself is not a factor, so we cannot cancel this x, the one that my black arrow is pointing to. However, x squared times x plus 2 divided by x, we can rewrite this to become x times x, so that gives us our x squared, and now we can cancel off factors x this way. So our final answer will be x times of x plus 2. Now typically we don't bother expanding out the x squared. Usually this is what we write, x squared times x plus 2 divided by x. We simply get x times of x plus 2. And our working looks like this. Cancel with the square, cancel with the x. Now we have some quick revision. A squared b is the same as a times b. Typically we don't expand everything out. A times b power 5, we got a times 1, 2, 3, 4, 5 of them. So when we simplify, we still want to cancel with common factors. So 1a and 1a, 1b and 1b, leaving us with a over b power 4. So usually we don't expand everything out. What we tend to write for our working is this. So we cancel away one common a, so we change the power this time. Right, the power from 2 became 1. Power 1, we don't bother writing. We've got 1b in common, cancel with the b, cancel with the 5, change it to become 4. So what we see will be a divided by b power 4. So similarly for part b, y plus 1, one of it is common, so we're left with 2. We've got 2 of those x plus 2 that is common, so we cancel this. Power 3 becomes power 1. So the solution, y plus 1 squared divided by x plus 2. So now we simplify the algebraic expression using a pencil. Divide by 5, 2 and 3. So we have 2 over 3m. Now same case over here, we still have 2 over 3 times of a minus b. For part c, we divide the numbers first. So 4. Now n power 4 on top, 1 n at the bottom, cancel away, we're left with power 3. Now please be very careful, this is n power 3, not n times 3. So we end up with n power 3 divided by 4. Last case, so 12 and 9, left with 3, 4. Cancel away x squared, we're left with x power 4. Cancel away y cubed, we're left with y power 2. So here, be very careful again. 4 is the coefficient. We don't have any more x. We've got y squared. We have divided by 3 and x power 4. Okay, so as you write the powers and the numbers, just be very careful about not mixing them up. Okay, next. Okay, before we go on, now we recall again. 4y. 4y refers to 4 multiplied by y. Then we have a plus. 8 is can be expressed as 4 times 2. Okay, so in our factorizing, we take out the common factor of 4 and we're left with y plus 2. So where did all this come from? This is the common factor 4, and after we factorize out the common factor, we're left with y plus 2. Exactly here, y plus 2. Similarly over here, a is the common factor. So factorize out a, Once you take a squared divided by a, we're left with a. Then copy down the minus sign. AB divided by a, we're left with b. Done. Now part C, at the first glance it looks like there are no common factors. But be very sensitive to 25, this can be written as 5 squared. And then we have this particular format, a squared minus b squared. So that gives us x plus 5 times x minus 5. For part D, your 9y squared can be written as 3y with a bracket square. Your 25 can be written as 5 squared again. So now we have our a squared, which is your 3y squared, minus b squared, which is your 5 squared again. So the factorized form says open bracket a. So a in this case 3y plus b. So plus 5. Open bracket again. It says a again. This time a is 3y minus b. So minus 5. And this is our factorized form. Now the next case, where we have 3 terms with a square in one of them, we can use our multiplication frame. So we want to end up with x squared, we want to end up with a negative 8. So which two factors multiply together to give us x squared? So our options will be just x and x. Now we need to consider which two numbers multiplied together gives us negative 8. So we tend to ignore the sign first. We think about the factors of 8, which could be 1 and 8 or 2 and 4. Do some mental calculation. Would having a 1 and 8 result in a negative 6x? Is it possible? So try that out. You can have 1 times x, you get x, and 8 times x, you get 8x. Now 8x and 1x, there's no way that we can obtain a negative 6x. So we know that it is not a good idea to select 1 and 8 as our factors. So let's try the next option. We have 2 and 4. So 2 times the yellow x, one of it, times this yellow x, we get 2x. Then 4 multiplied by this x, we get 4x. Look at it, 2x and 4x. We get, it is possible for us to obtain a negative 6x only if both of them have negative sign. Sorry, I made a mistake over here. This 8 over here is just a positive 8. Okay, so only if the 2x has a negative sign and the 4x has a negative sign. Now our x terms, they give us our negative 6x. However, in order to obtain a negative 2x, I need a negative sign in front of my 2, so that negative 2 times x gives me negative 2x. I need a negative sign in front of my 4, so that x times of negative 4 gives me negative 4x. And now the puzzle is solved. Negative 2 times negative 4 still gives me positive 8. So the factorized form is x minus 2, x minus 4. Now in part G, where we see 4 terms, so we want to pair them up. First two terms, we've got common factors, right? We've got 2 and a as the common factor. In the next 2 terms, we have b as the common factor. So let's factorize those out. 2a, we're left with 5x plus 4y. In the second pair, b is a common factor, so 5x plus 4y. Now we are not surprised that these two are the same. In fact, we expect common factors to appear so that we can factorize. Alright, take out the common factor again, so 5x plus 4y. This is the common factor. And we simply copy down whatever is that. 2a plus b. So 2a plus b. Part H, same thing. 4 terms, pair them up. Okay, I see common factors here, I see common factors here. So 2 times of a, x minus 3y, plus common factor is b, x minus 3y again. So here are our common factors and our quotient. So 2a plus b. Right now your common factor, x minus 3y, open bracket, 2a plus b. So common factor and the quotient. Just want to highlight now, students tend to forget the sign over here, the plus sign. Must remember to include. Okay, so in summary, we've covered the different ways of factorizing. We've got simple factorization, for example like this. We've got difference of squares, so a squared minus b squared. We've got the cross method. Okay, some of you might be more comfortable using the multiplication frame, and then we've got our grouping method for 4 terms. So whenever you are asked to simplify an algebraic fraction, we factorize everything, numerator and denominator. Okay, so using one of the 4 options here, then we try and cancel off whatever is common. Right, so 4y plus 8, we can do that. We can factorize that. That's our simple factorization. So 4 is a common factor, left with y plus 2. In the denominator, 2 is a common factor, y minus 3. So we know that we can divide our 4 and 2 by their common factor of 2. So we're left with 2 times of y plus 2 over y minus 3. Now in part B, x minus 2 numerator cannot be factorized any further. Now x squared minus 6x plus 8, we did that earlier on. X squared minus 6x plus 8, we get x minus 2, x minus 4. X minus 2, x minus 4. So factors that are common, this can be written as 1 times of x minus 2. So x minus 2 is the common factor, leaving us with 1 over x minus 4. Here we've got the difference of squares. Change of 4 to become 2 squared. So it becomes x squared minus 2 squared. That gives us x plus 2, x minus 2. This is the factorized form, divided by x plus 2 squared. So x plus 2 itself is a common factor, so cancel, left with 1 of it in the denominator. So x minus 2 over x plus 2. Okay, so now we move on to part D, where we want to factorize numerator and denominator. So 3x squared minus 10x minus 8. I'll be using this method this time. I want to obtain 3x squared. I want to end up with negative 8 here, and I want to end up with negative 10x. So draw a cross. Okay, so we start filling in which 2 terms multiplied to give us 3x squared. Definitely, we only have one option, which is 3x and x. You can put it the other way around as well. So now move on to the next. Which 2 multiplied to give us negative 8. So we can try 4 and 2, keeping in mind that one of them has to have a negative sign. Okay, so let's leave it this way first. We see what happens. 3x multiplied by 2 gives me 6x. Then we carry on. X multiplied by 4 gives me 4x. Now, 6x and 4x, look, it is possible to give us a negative 10x only if there's a negative sign here and a negative sign here. Okay, in both of the 4x and the 6x. Then I can have my negative 10x. However, for that to happen, in order to get a negative 4x, I must have a negative sign here. In order to get a negative 6x, I must have a negative sign here. Then I check back my work. Negative 4 times negative 2 does not give me negative 8. Remember we said that only one of them can have the negative sign. So the option of choosing 4 and 2 as the factors have failed us. What if I switch it around? We put 4 on top, right? So let's put 2 on top and 4 this way. So what if it is like this? Now 2 times 4 is positive 8. So I know that for this to be satisfied, one of them should have a negative sign. So let's carry on with our trial. 3x times 4 we get 12x. And x times 2 gives us 2x. Now this we are still able to obtain a negative 10x only if there's a negative sign attached to the 12x. So how can that happen? It can happen if I attach a negative sign here. So far so good. Then I do my last check. 2 times negative 4 is negative 8. So yes, I've solved the puzzle. The factors will be 3x plus 2 and x minus 4. So put that down in the numerator. 3x plus 2, x minus 4. Now these are equal, so don't forget the equal sign. Denominator, we've got our 4 plus x and 4 minus x. Because 16 can be expressed as 4 squared. Now, we see something very similar, huh? X minus 4 on the numerator and 4 minus x in the denominator. They're almost the same, but they're not the same. We want to try and make one of them be the same as the other so that we can cancel off. So I'm going to attempt to make the 4 minus x in green to become x minus 4. And we notice that if I were to change the sign from positive 4 to become negative 4, from negative x to become positive x, I get what is in yellow. So in order to change the sign, I need to multiply by negative 1. So this will give us negative 4 plus x, which is the same. But I cannot just multiply by negative 1 in the denominator and expect the original question and my working to be equal. So we multiply numerator by the same negative 1. In this way, we end up effectively multiplying both numerator and denominator by the same number, and the fraction remains equivalent. So this is our approach. Now this numerator's negative 1, it doesn't make sense for us to multiply it because then we'll be changing both numerator and denominator at the same time. Then there's no difference. You are unable to get common factors. So instead of multiplying negative 1 to negative 4 to the yellow expression, how about we park it in front? So this is what it will look like. Negative 3x plus 2 divided by, x minus 4 divided by 4 plus x and x minus 4. Now these two are the same, and I can eliminate them. So our final answer will be negative 3x plus 2, okay, we don't need the brackets already, over 4 plus x. Please be very careful of how you write this negative sign, this particular negative sign. Do not make it end up looking like this, negative 3x plus 2, 4 plus x. So it becomes very ambiguous. Does the minus sign belong to 3x only? Does it belong to the fraction? So this will not be accepted. Okay, in part E, we've got our 4 terms. So 4 terms, pair them up. First 2 terms, we've got 3p as a common factor, so leaving us with x plus 5y. In the next 2 terms, we want to factorize out negative 2q, so that we have again x plus 5y. How did I decide to factorize out negative 2q instead of positive 2q? Because I know I have to result in x plus 5y, x plus 5y. If I factorize out positive 2q, I would end up with negative x minus 5y. That doesn't help me. Okay, denominator, same thing. Factorize out 3p. So I'm happy because I see the same 3p appear already. So we have 7x minus y. Then I factorize out, since I factorized out negative 2q earlier on, I have a feeling that I can factorize out negative 2q again. So let me check over here. Yes, I can. So when I factorize out negative 2q, I end up with positive 7x. And happy because same again. Then minus y. Same. So I know I'm on the right track. Okay, so take out all the common factors. X plus 5y with the brackets 3p minus 2q divided by 7x minus y 3p minus 2q. We've got common factors. Final answer, x plus 5y over 7x minus y. Final question. So we see 4 terms. Usually we'll go with, pair them up. However, if we try to do so, we see that yes, we've got common factors here, but we don't have common factors over here. The z squared by itself is not doesn't have y. So we tried something different. We noticed that this follows the format a plus b squared to give us a squared plus 2ab plus b squared, where our a is actually 2x and then our b equals to y. So the same thing is observed for the denominator. So let's carry on. 2x plus y square minus z square divided by y plus z square minus 4x square. Now I want to rewrite this 4x square to become 2x square, so that both numerator and denominator, they are of the form a square minus b square, right? So a plus b, a minus b. You just allocate the corresponding a and b values. So in the numerator, we have our a, which is 2x plus y, plus b multiplied by a minus b, divided by denominator a plus b multiplied by a minus b. So it turns out we've got common factor. Cancel. Leaving us with 2x plus y minus z, y plus z minus 2x.